Good morning, good afternoon, good evening to everybody who's joining us today. Some of you might be joining us for the first time. So I will give you a little introduction about SUT. SUT is the Society for Underwater Technology. We are a multidisciplinary learned society. We aim to bring together organizations and individuals with a common interest in underwater technology, ocean science, and offshore engineering. SUT Plus is the subset of SUT for young professionals. We are created for developing professionals, graduates, and students, and are run by volunteers working in the subsea industry. Our branches are spread across the globe, as you can see, and you may even find one in the city or the country that you live in. You can follow us on our social media. If you follow us on YouTube, by checking out our YouTube channel, SUT Media, you will find recordings of the old webinars that we have held. And on our website, you will get a list of the future events that we will be hosting. If you sign up to our emailing list using the QR code here, you'll get newsletters with the latest updates. You can also follow us on the LinkedIn page where we post regularly. These are our contact details if you would like to contact us and get in touch. Without further ado, I shall hand over to Hugo and let him introduce himself and let us know more about USVs. Thank you, and over to you.
Thank you, Shruti. Thanks for the introduction and for the invite. I hope everybody can hear me well, and I'm sharing my screen right now to the presentation. Can you confirm, Shruti, that you are seeing the presentation?
Yes, we can see your screen.
Okay, good. It's a pleasure to be here speaking to SUT Plus. My name is Higuel Norões. I'm speaking on behalf of TideWise, and the webinar is going to be about unmanned surface vehicles and their applications. So a quick start with my background, just briefly. I'm a naval architect and marine engineer from UFRJ, the Federal University of Rio de Janeiro in Brazil. I have a master's in fluid mechanics by COPE in Brazil as well. And I was a visiting student in manned ship science in the University of Southampton in the UK in the year of 2012. I've been working with unmanned surface vehicles for a little bit more than 6 years. And since the university, from my undergraduate studies, I've been very involved on the design, manufacture, and operations of small crafts, especially electrical ones. I participated in solar boat regattas all throughout Brazil, which I designed and piloted, winning the national championship. It was very good. And I also worked with remote controlled boats, participating in a competition in Switzerland, Lausanne. It was a remote controlled hydrofoil boat, which was a very good experience as well. When I was in the UK, I had the honor to be a naval architect intern in ASV Global, which is now is called L3 Harris. In the time was the leading company developing and operating unmanned systems for the maritime industry. And since then, I've been working with those type of systems. So what are unmanned surface vehicles? Of course, those are most commonly boats without a crew, right? For the International Maritime Organization, they define the term, which is called MAS, Maritime Autonomous Surface Ships, which comes from the Maritime UK guidelines, which started being built in the early 2010s. Right now, there is a conversation about not using the term unmanned, rather using uncrewed or something like that to be more inclusive. So the term, which we will hear a lot in the future, will be MAS, which is the standard from IMO. So those type of systems can be classified in different sizes, different speeds, and weights. So let's take a look on the category that the IMO is setting right now. The first one is called ultralight. So those boats are under 7 meters of length. They have a max speed of 4 knots, and you can encounter hundreds operating around the world. You can mostly encounter them in Europe, in the US, Asia. China is the main place in Asia that you can find those type of systems, Australia, and of course, Latin America, and here in Brazil. Those systems are, those ultralight boats are mainly specialized in one job, one task. Most of them are doing bathymetry and survey. But our boat in TideWise, USV Tupan, is more of a multi-purpose boat. We can do bathymetry, survey, we can do metocean data collection, surveillance as well. There are a lot of applications that we can do with our boats. I'll talk about a little bit these specific boats later on. The next category is light, which are boats ranging from 7 to 12 meters. They have a max speed of 7 knots. If you go above that, you are in a high-speed craft classification, which is another story I will not have time to cover in this webinar. And you can see dozens operating around the world, mainly in Europe and US. You can find some in China and Australia as well. Those boats are mostly designed to do bathymetry, to do survey. They have special considerations for less pitch, less roll, to improve the data quality. And yes, these are one of the most common, this is the hot topic right now in unmanned surface vehicles. You can find a lot of groups designing and building and operating these light boats. The next category is small, which are boats from 12 to 24 meters. You have dozens operating around the world, mainly in Europe and the US. You can see that most of them are very fast because they are mainly applied for military applications. Those applications can be mine sweeping, missile targeting. You can do, of course, also surveillance for monitoring harbors, for example. Yeah, so mainly military applications for those types of vessels. And the last one is large, which are boats above 24 meters and 100 gross tonnage. You have very few prototypes running around the world, but you have dozens being built. And also you have one which is 78 meters long, which is due to be, well, it is already built, the prototype is built, and is due to increase the level of autonomy in the next decades, reaching full autonomous configuration in the year, if I'm not afraid, if I'm not wrong, is 2030, 2040. So it's a common question that we receive here in TideWise when we talk with our clients is how smart are they? How smart are those USVs? So IMO sets a degree of autonomy table, which you have a lot of levels to define how autonomous are they. You can see that the first one is a ship with automated process and decision support, where you have the crew on board. So crew is on board doing most of the tasks inside the boat or ship, and you have some autonomy control functions such as autopilot and things like that. The last level, let's jump into the last level, is fully autonomous ships, where you have no crew on board and the system can do decisions and determine actions by herself, right? And the two levels in the middle here are remote control, both of them. The first one, number 2, is a remote control ship with seafarers on board. So people is on board. You have people doing maintenance work, for example, but you can have some controls and operations that are designed by the control system, by the control functions. And the third level is a remote control ship without seafarers on board. So it's a better level of automation, right? The USV Tupan from TideWise is just under 5 meters. That's because we have a special regulations in the flag state of Brazil, in which things are simpler to operate the boats under 5 meters. You can see that the displacement of Tupan is 1,200 kilos, fully laden. For the naval architects in the audience, you can see that the displacement is quite high for the size of the boat. And it's very common on unmanned systems. The propulsion is diesel electric with 2 props, a driveline, single drive lines for each prop. The props are fixed pitch, and you have 4.5 kilowatts each system, each prop. This configuration, it's the best one that we, in our experience, that we find for the types of jobs that USV Tupan does. For example, you can see that the endurance is up to 7 days. This is doing mainly survey work, which you go for maybe 3 to 4 knots of speed. So you can be up to 7 days. And also for jobs in which the speed fluctuates a lot. So having a diesel electric configuration is quite good. The props, the electrical motors are good for a fine level of control of speed, electrical motors. And they are getting energy from the battery bank, which is charged by the diesel genset. So the maximum speed is 6.5 knots. We have a payload maximum power of 1 kilowatts. And the communication can be, when you have line of sight, via radio link up to 18 kilometers. And you have the mobile network as well. If something goes wrong with the radio link, you have 4G. And of course, if you want to do jobs that you have over the horizon operations, so you don't see the boat, you can have satellite communications as well, right? This increases the cost of the operation. The trend in the market is that the cost is going lower and lower for satellite communications, but some clients do need this functionality. TideWise, we are a company based in 4 pillars. We provide data and we provide more value because our boat can stay longer in the sea, and our boat is capable of having less motions as it has an active compensation system for less roll and pitch. So the quality of the data that we collect is more valuable. We provide less risks as you don't have any crew on the sea, or you don't have any risks on injuries, or you have less risks on injuries and any problem that can happen with people, seasickness, for example. And you have less environmental impact because the same job that you perform with a conventional boat, you do with an unmanned system that is smaller and consumes less power than burning less fuel, right? So what's the application, right? So what for? Why do we have autonomous vessels? They are mainly used to perform repetitive, hard, dangerous, or costly tasks in the sea. So let's talk about a little bit of the applications that we see very commonly. First one, of course, is bathymetric survey. It's the main one right now. You can fit the USV with a multi-beam echo sounder, sub-bottom profiler, a CTD, and as I said before, our system is equipped with an anti-roll system. And you can see that most of the vessels that are coming up have some type of configurations to dampen the motions. This can be on the design of the hull lines or even an active system like ours. The next one is ROV and AUV tracking. You can perform USPL calibration, and you can monitor the laying of submarine pipelines, for example. Next one is autonomous draft reading. In TideWise, we have our own draft reading algorithm. It's the first in the world to be developed specific for an USV. This type of job is commonly done with people on board next to the side shell of the ship. It's a very dangerous job, but the USV can be fitted with cameras and algorithms capable of defining the drafts in the bow, in the midship, and the stern. So this can be made automatically. Next one is environmental monitoring. We can do metocean data collection. We can serve as a drone-based platform. I was speaking a bit. You can fit a fluorescence sensor to check oil. You can have a DCP, a LiDAR for wind. You can measure wind. You can use that for offshore wind farms that are popping up right now. It's a very hot topic in Brazil, especially to measure and define the potential of good locations to install offshore wind farms. And you can do inspection and monitoring. You can collect images which are geo-referenced. You can have LiDAR to inspect structures. cameras, multi-beam and sounder as well. You can use this for oil rigs, oil platforms. You can use for buoys, any infrastructure that you want to inspect and monitor. So applications by location, let's say, if you think about harbors, you can do survey, because harbors some of them rely very much in dredging. So you need to check every time you do a dredging, before and after you do a dredging, you need to do a survey. You have surveillance as well for safety. In Brazil, we have some ports which are not very safe, so you need to monitor those areas. And as I said, draft marks reading. For the coastal context, you can have survey, of course, aquaculture, monitoring as well. You have in Australia a lot of aquaculture. In Brazil, it's rising. You can do the monitor of those aquaculture farms as well. You can have mammals monitoring. I think you all know the regulations. If you are doing such as drilling operations and you spot a mammal nearby, you need to stop the operation. So the USV can be fitted with hydrophones and microphones to check for the mammals. You can do environmental monitoring, like data water collection, the water quality collection, and you can do also cargo transport. For the offshore situation, you can do U-wide survey, which is doing survey of an FPSO, for example, which you don't need to take the FPSO to a yard. You do it along the ship. You can use an ROV or IUV to help this job. You can do oil spill monitoring, metocean data collection, of course. You can do cargo transport between platforms, for example, or between wind turbines in an offshore wind situation. And you can do USV and ROV subsea inspection as well. So there is also the application of oil spill monitoring, in which TideWise has a good experience on. We just finished a demonstration of a prototype last December last year. We integrated a drone, which was autonomous, fitted with visual and thermal camera to check oil spills. The drone was developed in partnership with a local university, Federal University, and our USV served as a base platform for the drone to land. But the USV was also fitted with a fluoro sensor to check in loco the presence of oil in water. So I'll play this 3-minute video just to show you how it was.
Foi identificado um desafio operacional na área de segurança, nas operações tanto da Noruega, do Brasil e de outros ativos ao longo do grupo ARIEL, que precisavam justamente desta tecnologia.
A gente juntou todo mundo numa sala e fez um brainstorm gigantesco de elaborações de conceitos. Dali surgiram várias ideias de como fazer a integração do drone com o USV. E aí toda a parte de hardware como a parte de software, né, foi levantado assim, conceitos que poderiam funcionar. Dali a gente partiu para um projeto básico de engenharia e identificou quais eram os grandes desafios técnicos. Então quando a gente chegou nesse ponto, a gente partiu para a etapa de simulação. A gente criou no ambiente de simulação, né, modelos do drone e do USV, da embarcação autônoma, e começou a programar como eles deveriam se comportar e tentar identificar quais eram os desafios de integração. E aí partiu para a integração de hardware. Então, construção de protótipos para realmente verificar se o que estava simulado em engenharia é materializado em hardware. E aí isso foi feito ao longo do tempo, até o ponto que a gente chegou hoje, né? Que é realmente verificar tudo funcionando junto, hardware, software, com todas as coisas que não são muito previsíveis, né? Perturbações da natureza. Você, por mais que modele, você nunca sabe exatamente como vai funcionar, e aí tudo funciona de uma forma robusta.
A gente desenvolveu o projeto ARIEL, que é um sistema 100% autônomo, não precisando ter pessoas, né, envolvidas nessa operação, e você reduz também os falsos negativos, porque é um sistema que vai estar em loco, ele vai em loco olhar e detectar uma possível mancha através de tecnologias de visões, né, de câmeras especiais que estão instaladas no drone, e você zera essa questão de falso negativo, reduzindo também os custos.
COP fazendo essa parte de pesquisa e do controle do drone, TideWise fazendo a parte do controle do barco, né? E todas as reuniões que a gente participou com a Repsol, equipamentos do laboratório a gente emprestou para ajudar no projeto. Foi uma união de esforços e realmente todo mundo trabalhou em equipe.
A gente conseguiu, com o suporte de todo o pessoal da TideWise, o pessoal da COP, trabalhando junto, o engajamento e toda a resiliência da equipe, a gente conseguiu, tá aí o resultado. Hoje a gente fez toda a demonstração do protótipo e a gente conseguiu atingir todos os desafios que a gente propôs há 2 anos atrás.
So let me go back to the presentation. So as you can see, this project was, the client was Repsol Sinopec Brazil. It's the Repsol group here in Rio de Janeiro, in Brazil, of course. As you saw maybe you saw on the last scene of the movie, the drone was also fitted with a tether system. It could also be fitted with a tether system to provide a high autonomy of the drone flying by. The drone could fly for up to 5 hours in a row. It's a very good project. I'm very fond of it. We had the pleasure to work with Stable. It's a company in Norway who develops stabilized platforms, which was very beneficial for the drone landing. It was really good. And well, yeah, I'm very fond of this project. You can check more in our website. So let's talk about the regulations. Right now, up to 24 meters, you are non-SOLAS, so you can only use the flag states. Of course, some countries does not have the flag states yet defined for autonomous applications. Most of them are already defined. The International Maritime Organization is planning to issue the first regulations in 2023. Right now, you have the guideline, which is spreadly used by the industry, which came from the Maritime UK. As I said before, it's a very good guideline. You can check on their website. Now, a good point is that insurance companies are covering USV applications, and the man-in-the-loop is the most common operational concept right now. It's very unlikely that you will see on an autonomous vessel or ship operating without a man monitoring what is going on. So I'll do a quick overview of the TideWise design process, how we could develop the USV here in Brazil and the past experience that we have. TideWise is a company that provides safer, greener, and cheaper maritime operations. We have a business model in which we are a service provider of data. We collect data at a marine environment. We are turning 2 years old. We have a lot of qualified personnel, a lot of master's degree, a PhD as well. And we have accumulated experience mainly from Rafael Coelho, which is working with USVs for more than 11 years. Rafael Coelho was the head of engineering of ASV Global, now called L3 Harris, developing dozens of autonomous vessels for a long time. And Sylvain Joyeux, which works with robotics, has a lot of experience in maritime robotics as well for more than 14 years. The TideWise design process that we are very happy with and have been using for a long time is the double diamond approach. We know that for ships, we are mainly using the Evans spiral. Most of us naval architects and marine engineers, we know about the Evans spiral. It's a conventional way to design ships and boats, but for the USVs are very innovative products. We use this double diamond approach, which comes from the product design industry. So first we define the problem. We spend a lot of time telling the story of what the USV needs to accomplish. And then we come up with a discover phase in which we brainstorm a lot of concepts that could work for this type of problem. For the define phase, we just cross the concepts that we think that would not work very well. So we are crossing all the brainstorming that we did to define the concept that we are going to develop. So when we define the concept, we do the requirements matrix capture with the client. The client can be internal as well, can be ourselves. And in our experience, it's very good to do an initial CONOPS, concepts of operations as well. So then you define all the behaviors and all the states that the USV needs to perform in his lifetime. But then we go to a develop phase in which we are doing mostly the basic and detailed design, as we all know. And then we go to the delivery, in which is producing manufacturing drawings, doing the bill of materials, and then manufacturing and testing, prototyping, testing, and delivering the solution. That's the methodology that we are happy with and using for a long time. We do agile development coming from the software industry. We try to work together with hardware and software team working together in an agile situation. We have fixed squad with multidisciplinary team, electrical engineers, mechanical engineers, naval architects working the same project together. We have 2-week sprints to define the tasks to be done, and we are using Kanban boards to manage those tasks. The anatomy of the project that we do is first we start with the project deliverables, which are accepted by the client. And then we break down those deliverables in milestones. They have due dates to be completed. And those milestones are split up in goals. Those goals are used mainly on the sprints iterations that we do. So each sprint has a number of goals that we need to complete. And then for the individual or small group chunks of tasks and jobs to perform, we use tasks, as everybody knows. That's it, just a quick overview of the TideWise design process. And I want to end my presentation here with a call for action for you guys. 3 questions here. First one, are you ready to be an active driver for change? The change is coming. I know that most of you that are attending this webinar works in the maritime industry. Maybe you are engineers, maybe you are salespeople. Do you know that the change is coming? You are attending this webinar. And what is your position in this change? Are you actively doing something for this to happen, or just passively looking for what is going on? The next question is, what organizational operation that you can make an USV perform in your current job or position? Do you see that any tasks can be operated and done by USVs? Think about it. And number 3, what benefits you bring to your company in doing so? So if you implement the use of uncrewed systems in your company, what are the benefits that you bring? What other challenge that you can tackle? What are challenge that you can unlock? Yeah, so that's my call for action for you. I urge you to embark on the autonomous revolution, and thanks for attending. Thanks for attending.